Okay, before we graph this one, let's just remind ourselves of what sine of x looks like, the basic form of sine. This has an amplitude of 1, and if you don't have a coefficient, then it's a 1, so it's a period of 2 pi. So what that means is you start at the midline, you start right at the center at 0, 0, and you go up to the peak of your amplitude, down to the bottom part of your amplitude, then you should repeat yourself every 2 pi units. So we call that 1 period of sine. So this one has some manipulations. First, the negative sign out front, all that means is you start at the center again, but you go down first and then up and then come back to the start. Okay. This pi over 3, that's our horizontal shift because that basic form is a sine b parentheses x minus c minus d, or plus d, sorry, plus d. So b is the coefficient of x. You've always got to factor that out if you want to put it in this form. So b is 1, so you could factor out a 1. That doesn't really change anything though, right? So what that c does is that it moves that starting dot. Instead of starting at the origin, our graph is going to be pi over 3 units to the right. A minus pi over 3 moves us pi over 3 units to the right. So instead of starting here, we're starting over here to do our sine wave. Oh, but then there's a vertical shift. Okay, so we move pi over 3 units to the right for our horizontal shift, but this minus 1 means we move our starting dot down one place. And now we're ready to do our sine wave. Instead of starting here at the origin and doing our sine wave, we're going to start down here. It should look something like this. Now, exactly how high should we go? We can calculate that because the amplitude is 3. I know there's a negative sign, but the amplitude is always the positive version of a. Okay. So if we start at negative 1 and if our amplitude is 3, it means we go up 3 units on the y-axis. So up 1, up 2, up 3. This is how high we're going to go. And then likewise, we go down 3 units, negative 2, negative 3, negative 4. That's the lowest place we should go. So we go up to positive 3, we go down to negative 4, and then we've returned to our midline. And we're about to start another period there. Now, what is this x-coordinate? We can actually calculate exactly what that x-coordinate is because we know we've shifted pi over 3 units to the right, and we know our period is 2 pi because remember to calculate period, to calculate how long you go until you repeat yourself, RB is 1, right? So our period is 2 pi. But we've been shifted pi over 3 units to the right, so this x-coordinate is exactly 2 pi plus pi over 3. Then we repeat ourselves again. The next one is going to be on the x-axis. This is going to be 4 pi plus pi over 3. Because the period is 2 pi, but we have to compensate for the extra horizontal shift. And so that should be the graph you see in Desmos for this one. This graph is cosine. Cosine is a sinusoidal wave. It looks just like sine, except it starts at the top of the amplitude. So the graph of cosine of x without any other numbers looks like that. At x equals 0, it starts at the top. So our graph over here has undergone some shifting. There's a plus 1 shift, so instead of starting at 1, we want to move up 1 unit. But then we also need to take into account the amplitude, okay? Usually this starts at the peak of the amplitude, right? But the amplitude is 2 now. So there's our amplitude of 2, and this would be the graph of 2 cosine of x without any other numbers. But we're at 2 cosine of x plus 1, so we've got to shift that up 1 more unit. So our starting dot isn't at y equals 1 like the first graph I drew. It's at y equals 3. And then we'll want to remember the amplitude is 2, which means we go down a total of 4 units. Because remember, the amplitude is half of the distance from the top to the bottom. Okay, but anyway, it was, cosine of x starts at 1. But the amplitude is 2, so that brought us up here for our starting dot. But then the plus 1 made us have another vertical shift up 1 unit to y equals 3 for our starting dot. But there's also a horizontal shift. To figure out exactly what the horizontal shift is, you have to put it in that general form I gave in my first video. You got to factor that 3 out of everything inside here. So this looks like x minus pi over 9 on the inside. So if you have a coefficient of x that's not 1, you've got to factor that number out of both terms in the inside. What I did was I did pi over 3 divide by 3. That gives me pi over 9. So what that horizontal shift tells us is that we don't start at x equals 0 anymore. Now that sinusoidal wave starts at pi over 9. So this is our starting dot. And since the amplitude is 2, I'm going to go down 1, 2, 3, 4 before I start coming back up. And then the last part that we need to identify is, hey, where are we on the x-axis when we start repeating ourselves? That's the period. That's determined by using the period. Okay. So the period is of sine and cosine is always 2 pi divided by technically the absolute value of b. I haven't been writing that, but it's always the positive version. Okay. So b is 3. So my period is 2 pi over 3, right? So this x-coordinate isn't 2 pi over 3 exactly because remember we already did a horizontal shift. It's 2 pi over 3 plus that extra sliver of area right here, pi over 9. So that's the location on the x-axis when we start repeating ourselves. And then this next one would be 4 pi over 3. You just add another 2 pi over 3 to it. You just add another period. So this next one would be 4 pi over 3 plus that extra sliver on the x-axis that we had to add because of the horizontal shift. Okay, and that's everything. So use desmos.com/calculator to help check your work on these ones too.